Welcome back to our trigonometry series. Today we are up to section 1.4 where we will be looking at the trigonometric functions. Now this might sound familiar to you if your brain remembers this stuff from our geometry days. And our good old friend, the right triangle. And our good friend Pythagoras. We know that a squared plus b squared equals c squared for a right triangle. So let's take a look at this angle here between side A and the hypotenuse C, and we'll call it theta. This is a review of the trigonometric ratios that we covered in 5.6 in the geometry series. But as a reminder, the cosine of an angle is the adjacent side over the hypotenuse, the sine of that same angle is the opposite side over the hypotenuse, and the tangent is the opposite over the adjacent. They are fractions, but really they're ratios comparing two lengths of the triangle. So in this case, the cosine of theta is a over c, the sine of theta is b over c, and the tangent of theta is b over a. And as an example, here's a 3, 4, 5 right triangle. And you can see how the different trigonometric functions, or ratios, end up. So let's go back to our friend, the unit circle. As this circle centered about 0 and has a radius of 1. And here we're showing a generic angle of theta. Let's zoom in a little bit. And let's look at this point here. This is where the circle and the segment that's from the angle actually meet. Next, let's draw a line straight down to the x-axis, creating a right angle and thus a right triangle. This point is some value of x away from the origin. It is also some value up in y from the origin. So we can say that the point coordinates are x, y. So let's look at those trigonometric functions again. Cosine, sine, and tangent. Well, cosine is the adjacent side over the hypotenuse, or in this case it's x over 1. We have a unit circle, so the radius is 1. So in our triangle, the hypotenuse is 1. So really, the cosine of theta is just x. Likewise, for sine, it would be the opposite side over the hypotenuse, or y over 1, or just y. And tangent would be a ratio of y over x. Keep in mind, the simplification we show here only works when the radius is 1. It might be better to think of it as a generic ratio like this, with r as the radius. And because of our good friend Pythagoras, we know that x squared plus y squared will equal r squared. It's the same formula, just rewritten using the variables that we have here. And if we took the square root of both sides, we can say the square root of x squared plus y squared is equal to the radius. So let's take a look at this example. Theta is somewhere between 90 and 180 degrees, or pi half and pi radians. The point lives at x, y. But this time x has a negative value. We are to the left side of the plot. We are in the negative zone of x. Still, cosine of theta is x over r. So the cosine of theta will be a negative value because x is a negative value. What about the sine of theta? Well, y is still positive. So the sine of theta will still be positive as well. The sine, positive or negative, of sine, cosine, and tangent depends on which quadrant the point lies. And remember, the coordinates can be simplified to cosine theta, sine theta for a unit circle. Let's jump over the whiteboard and do some examples. Okay, let's go up here, and let's say we have a point in space, and its coordinates are 3, negative 4. We want to find the exact value of cosine theta and sine theta, assuming that this point is on the terminal side of the angle. So let's just draw this up real quick. So we have little arrows. We know we have our x or y axes. So x is 3. So we need to go over 1, 2, 3. And y is negative 4. We're going to go down 4 because y is negative. So P is over here. And we can draw our line like this. and maybe imagine, a little dotted line like this, and we've created a right triangle. Now to get to this point, we have to start here, and our terminal position is over here. So theta is really this angle all the way around is theta. So let's write down our equations here. We know that cosine of theta is equal to x over r, and sine theta equals y over r. Well, we know x and we know y, but we don't know the radius. So we're going to take this, we need to know this distance here. We're going to blow this up just a little bit. I'm going to say it's about this big, like this, like this. All right, we've come down 4. So this side has a length of 4. This side has a length of 5. But we also have our equation. We know that, let's even get this in here. The radius is equal to the square root of x squared plus y squared. So you might already know by looking at this 3 and 4 what this number is going to be, but let's do the mathematical stuff here. It's the square root of x squared. X is 3, 3 squared. That's a niner.
Did I catch a niner in there? Were you calling from a walkie-talkie?
No, it's cordless.
Plus, really, y is -4, right? The distance from here to here is 4, but the y value is -4. So really, it's -4 squared. Now, it still ends up being 16, but let's write it out. So 9 plus -4 squared, that gets the square root of 25. That equals 5. So we know this is 5, and this length here is 5. So the radius, r, is 5. So if we can rewrite this, the cosine of theta is 3, the x value, over the radius, 5. And that's it. And the sine will be the y value, -4 over the radius, 5. So while we're at it, what about the tangent? Well, tangent is y over x. Remember, y is actually a negative value. It'd be -4 over 3. So here we have our 3 trigonometric ratios for this value of theta. Let's clean this off and do one more example. This time we're going to start saying that the sine of some theta is equal to -3/5. We're also going to say that the point P is in quadrant 3. And the question is, what is the cosine of theta? Well, again, we're going to write out over here. We know that the sine of any theta is equal to y over r. So we already know that, we'll jot it down here, y equals -3. We already have one piece of the puzzle, and we've been given r. R is 5. We'll put it down here maybe. R equal to 5. And we also know that x squared plus y squared equals r squared. We have a y and we have an r. So we know that x squared plus -3 squared is equal to 5 squared. So we rewrite this as x squared plus 9 equals 25. We'll subtract from both sides. We get x squared equal to 16. So let's take the square root of both sides. When we do that, we've got to remember to add our kind of plus or minus in here. So x equals 4 or -4, because both of those would solve this equation or this equation, right? So which one is it? Well, the clue here is we know the point is in the third quadrant. So let's just cram in a xy axis here. We know that y is -3. So it's 1, 2, 3. It's down here somewhere, and it's in 1, 2, 3. It's in this quadrant. So x has to be a -4, right? If x was 4, our point would be over here in the fourth quadrant. But we know that the point is in the third quadrant. So we go 1, 2, 3, 4. to be over here in the third quadrant. And this is our theta. 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 Finally, what would our tangent be for this? Again, it's equal to y over x. Y is a negative value. I have room over here? I do. Y is negative 3. X is negative 4. So these would cancel out, and the tangent would equal just 3/4. That's it for today. We'll see you next time.